This video will continue our configuration upload operation development. We will now go into step 4 of the 6-step programming process and take a look at what that requires. Let's go to the editor. Again, we're systematic about this. It's called iterative refinement. We're going to put things together from top to bottom as we specified them. It turns out this step 4 is pretty easy because all we do is follow our instructions. We've brought the main data in here. We've got these parameters to the main function, and we will go ahead and develop things as they come along. So we're going to start at the top. Our file here is going to be printf. Give it a break right there. Config file, upload program, and then it's underlined. And so that's our display of file. I'll go ahead and now set up the rest of the code here. We can take a look at argc here. That is one of our parameters that tells us the count of the arguments. If it's less than 2, then somebody forgot to put the file name in there. What we'll do there is we'll say error, program requires file name for config file. Notice no end line here, so it continues as command line argument. And there is an end line, and we terminate the program. We return a non-normal return, which is anything other than 0, back to the system. We copy our string argv1. We could use this in the parameter, but it's a whole lot better to make it readable. So we copy what that argv1, it's the second item in that argv element. The first one is the name of the program. Copy that into config file name. Now we've got a self-documenting variable. Get our config data, put it in config file name we're going to use, and we're going to pass, you can think of this ampersand reference as, it's kind of a reference parameter. Later on it's called that in C++, but I like to look at it as the address of. So when we go into config access C here, and we look in this program right here, we're passing it a pointer, so this pointer will pass back the address of this pointer. And that's how that's going to work. So we're passing in the reference, we're saying address of that, and we'll get it back. We'll get the config access result back here. We're going to take advantage of the fact that our string utils.h already has a no error type def. It already has one defined. So we'll just use that for right now, and actually we'll continue to use it. It'll be a great one. If that's the case, we'll display our config data. And what we might want to do on that is put a very brief display in this display config data. Let's do that now. I have placed this in here so that this will actually report when we're running our dummy program. We'll see that. I've also gone ahead and done it for the display config error. So when this is called, we'll have some evidence that the thing is running or doing something here. And our display config error will happen here. And that's our function. And then our clear config data, again, because we want that null to be returned, we will pass this in as the address of config data. When it lands inside of config access and comes back, it will report back the address of this pointer. So we'll get that working for us. Now I want to go ahead and compile this. We've got a little bit of a problem that we'll have with this. But I want to go ahead and compile it and see what's going to happen. We'll clean it and we'll compile it. And we have maxstrlen undeclared. Now that's kind of strange because we did declare that. Let's go ahead and take a look at what we did. In our string utils.c, we declared maxstrlen. But here's what we didn't do. We didn't make it external. So it couldn't be seen outside of this HC area here. If we make this right here a copy and set that to maxstrlen, save that guy. These are updates and modifications we'll do as we evolve this system here. Then when we call this, it should know what that is. Let's see what happens. So a config data is undeclared. Let's go ahead and see what that is. Config data. I have a data pointer here. We find that this is on line 63. Let's go look at line 63. And sure enough, it's config data when it should say config data pointer. I'm allowing these little mistakes to happen because I really need you to be able to figure out what's going on when you see these pop up. We have fixed that. and we need to save it. So that's now saved. Come back here, and we have a clean compile. So coming back here, we can come back to the top. We have set up our variables. We found Max Sterling. We had to dig for it a little bit. Config data type, we know what that is because we created that in our config data access here. Got that figured out. These are structural things. The key point here is we want continuously healthy compiles and the potential to run. In fact, this program will run. It won't do a lot. Let's do one more thing here. We'll report all of these. I'm going to make a copy here. I don't always do this, but in this particular case, it might be helpful. So we'll say get config data function called here. We've got our display, our error, and our clear config data. Let's go ahead. We'll put one right there. And that's clear config data. So when we come back out here, we can say /config upload prog. And it says program requires file name for config file as command line argument. We can always see a little bit of a bug right there. We want to fix that. We can put a space in it. Program terminated. And that's exactly what it's supposed to do. So that's good. We've tested that out. I want to fix that one text part right away here. So we'll put a space right here. We could put it either place here. What we can now do to fake this is actually put in, if we do an ls here, star.cnf, we know that we've got a config 0.cnf. I'm going to go ahead and recompile. Happy compiler. I'm going to go ahead and rerun, and this time I'm going to say config 0.cnf. Truthfully, we could put anything in there because it doesn't matter at this point. It will later on. But we'll take that and put it in there. We get our get config data function is called here. Display config data function is called here. Clear is called here. Because we have a display, we're good. And we didn't get a display config error there. So again, important point. This program runs. It doesn't do very much. But this is a fully running functional main function, and I don't have to come back and look at it again. I've got to fill in some blanks now for the various functions that are going to be needed for this. And as I develop these functions, I'll be developing some other ones. But that's a step 5 operation and later a step 6 operation. So we'll come back to the beginning here, and we are wrapping up this particular part. We're done with step 4. Really isn't difficult because you really just plug in things and prove it works. And now we're ready to go on into step 5, where we design the functions that we will implement in step 6.